All right, welcome everyone. My name is Mildred. Today we are going to look at MySQL database management system from the basics, and we're going to look at different SQL concepts that we have learned so far and introduce new concepts. We have been using the Secular database as an example database for our practicals, and the reason we use Secular is an old one which is not as properly structured as modern or the most recent version of MySQL or recent version of SQL, sorry, and it will help us to be able to walk around database structures that we did not create. And then at the end of today's lesson, we're going to look at how to create our own database from specification to help you with assignment 3. We have said that the basic commands to use with SQL is to select the database first. So we want to use the Secular database, for instance. We use Secular like this. So for the pre-recorded videos and for most of the students in this class, MySQL Workbench is the choice of what we use to do our practice. But for the purpose of those who have an outdated operating system and are not able to use MySQL Workbench, I'm using phpMyAdmin. So we use Secular like this as the command, and this is going to select the database that you want to use when using MySQL Workbench. To list the tables that are in that database, when we select the database, the Secular database here, we can use the command show tables like this. And this, when we run, will show us all of the tables that we have in the database. We also looked at how to get all the data in a table. For instance, we have a customer table. We use the select statement, and the syntax that we have used is to write select, and then we use an asterisk to mean all columns. So when you see an asterisk, it means you are selecting all columns. So we say select asterisk. So we're selecting all columns from the name of the table. The syntax is select column name or asterisk to indicate all column from the name of the table within the database. The table we want is the customer table, so we'll write customer. So again, you have to take note of the syntax. Select, either you use an asterisk to indicate all columns, or you list the columns you want as a comma-separated list. When we select all from customer, we can see the different columns: customer ID, store ID, first name, last name, email, and the rest. If we say we don't want to select it like this, we want to select specific columns. Let's say we want to select the email. So we'll say select email from customer, and it's only going to give us the email column of all of the customers. So in the event that you have like a newsletter that monthly is sent to people who subscribe to getting newsletters, and you have the users table, and you have them check the checkbox that says subscribe to newsletter, and you verify that, okay, in the database they have checked subscribe to newsletter, then it checks their email column and gets all of the emails of all the customers who subscribe and automatically send the email once it is published without you having to enter emails. Or like I send an announcement on the school portal and everybody gets an email. It's the same structure. Just go to the email, go to the students table and look at the email addresses of everybody registered for this course. And when I put this announcement, send all of them an email. These are the use cases of things like this. So I like using use case as an example, so that when you are practicing it, you can imagine why this is useful and why you need to understand it and where you will apply it when you start building softwares. We need to understand this at its basic form before we can write it within Python or within other scripting language to be able to extract data from different sources. We have operators that we have tried to use, like the where clause, if we want to select based on a condition that we have looked at. And we also say that the syntax is select column names or use asterisk to indicate all from table name where, and you specify the condition. Let's say, for instance, we want to select everything from, or want to select just the title of a movie and the release year from the film table where the release year is 2006. We can now say we are selecting title and we're selecting release year, and we're selecting this from a table called film where the release year, which is the column of interest, is equal to 2006, like this. And then it's going to look at only the title of the movie where it is 2006. Okay. We also have other operators, like we want to do more than one condition. Let's say we want to look at two conditions. We want to check if both conditions are true or if one of the condition is true. So for instance, if we say something like we want to get the title and the release year and maybe the rating from the film table where the release year is 2006, and at the same time the rating of the movie is PG, something like that. So if you have, like we use the Netflix example, where you have a kids account, the account is a kids subscription account, and then you want to put out the menu of the movies on the screen for the kids, like what runs behind the hood, where you see, you just click on Netflix and it displays the list of movies. For the kids account, it automatically filters all movies that are not rated PG, or maybe they're not rated like 13 or rated. So that code that runs underneath is to just tell them that if this account is the kids account, you select all the movies from wherever it is stored where the rating is PG. So it just automatically filters the movie. And so when the user log in and the account is recognized as a kids account, then it only gives them movies that are kids friendly. So things like that. And so we write it like this. Select, we say we want to select the title, the release year, and we also want to select the rating from the film table where the release year is equal to 2006, and at the same time, so we use AND operator, and rating is equal to PG, like that. And then when we say go, it's going to give us all of the movie titles and the release year and the ratings, and we'll see that all the ratings are PG, so we don't get any movie that is not rated PG from there. We also looked at the topic called joins, where we try to take data across more than one table, and we join this data based on something we call a predicate. That is the common column that they have. For instance, we have the actor table, we have the film actor table, and the film table. And if you look at your course resource for last week, you would have seen that we had a document that shows us the structure of the circular database. And we can see that the actor and the film table are linked by the film actor table. The film actor table has an actor ID and the film ID. The film table has a film ID. So the film table and the film actor table are linked by a film ID column. They have a common column called film ID. And this common film ID column are foreign keys. So the film table has a film ID, which is the parent film ID. The film actor table have a film ID column, which is a foreign key from the film table. We're going to look at foreign key before we end today's lesson. What I'm just mentioning is for you to see it now, and then we'll discuss the concept of foreign keys. When we go to the actor table, we have an actor ID column, which is the primary column here. And when we go to the film actor, we have an actor ID table, which is now a foreign key from the actor table. So this way we keep the integrity of the table together, where if you update the actor table, it updates in the other places where actor ID is mentioned. If you update in the film table, you update in the place where film is mentioned. So what we use foreign keys for is to do things in one place and it applies everywhere. So what we do is just reference where it was created, who the parents are. So foreign key concept is just like having the last name and then we have a lot of children. The person who has that last name has a lot of children or a lot of family members that bears that last name. The person with the last name is the parent. The other people who bear the last name are the children. So exactly like this. All of this use the actor ID column, but who owns the actor ID? Where did it originate from? That is the parents table. And then the other places that use it are like the child columns for that table. So that's the concept of it. So we use this common predicate to be able to join records or data from across multiple tables. Let's say we want to be able to get data from the actor and the film actor table. We want to select like the first name and the last name from the actor table. We want to select the actor ID and the film ID from the film actor table. And then maybe we want to select like the title and the description from the film table, so that when we see a film ID like this, if we go to film actor, this actor ID we can see here. So we don't know by looking at this what the name of the actor is. So we want to create a record, we want to create a table on the fly where we have the name of the actors from here, and then we have the title and the title and the description of their movie from here, all in one table. So in one table we can see the name of the actor with the actor ID, the name of the film, and the film ID, the title and the description, all in one table. And we don't have that kind of table here. And so we said we can use joins to do that. When we use join, we only display the results, but we can save this result as a new table we call a view that we're going to look at shortly. But first of all, let's do this. We want to get the first name and the last name from the actor table. Let's say we want the actor table to be represented by the letter A. So we'll say select A dot first name, A dot last name, and then we want to get the title and the description from the film table, for instance. So we'll say B dot title, B dot description, and we want to get the actor ID and the film ID so that we just know the ID one time. C dot actor ID, and this is from the film actor table, and C dot film ID. So when you specify all of the columns you are getting with this from the different tables, we want to tell MySQL to know what A is, what B is, what C is. And we want to say, how do we link these three data? There has to be something that we can link them. How will it know that this rows in this particular table is data for the rows from another table? That's why we need the common predicates to join them on. And we have said that the actor and the film actor table have the actor ID in common, and the film actor table has the film ID in common. And so we're going to use this as the predicate. And we're going to say, we're selecting all of these from the first table is A. And so we say actor A. So we're telling MySQL that actor, when we see A, know that A means actor table. So from actor A, and then we want to use inner join. So we are going to be joining. So it's the actor and the film actor table that have the actor ID in common. So we're going to be joining film actor. And film actor is C. So we say inner join film actor C. And then on what? What are we joining is on. And we said that on A, since now we know what A is, we can now use A without using actor. A dot actor ID is equal to C dot actor ID. We have another condition. We could do another inner join. So we want to join the B, and B is the film table. So we're going to join inner join film B on B dot film ID is equal to c.filmID. So what we have done here is taking the different columns from 3 different tables, and these 3 different tables have a common predicate. The actor and the film actor table have the actor ID in common. And so the predicate we're joining on a.actor ID is equal to c.actor ID. The film and the film actor table, that's B and C, have the film ID in common. And so we are joining on b.film ID is equal to c.film ID. And when we say go, we have this joined together, and we have all the movies acted by different actors, their description, the actor ID, and the film ID in one go. So we can see it like this. So in the event that we do not want to always run this query, we want to have a view where this is stored in. When we say a view, it's just something that stores the result of this query, that you don't have to run this query again. It's like a table, but you cannot edit, update, or run table operations on it. It just automatically, when you update the tables that are concerned, the data there changes. We create view like this. Create, and we always have this good practice of trying to figure out if this already exists, replace it. If it does not exist, create it. So we use create or replace. And write is create or replace view, and give the view a name. Create or replace view, let's say the view is, let's call it movie details, for instance. So let's say create or replace view movie details, and has, so what is it that the movie detail view is going to be? We can put a pair of parentheses and put our join in it. This time is going to store that join as a table. So you don't need to run this query or always write this join every time. So if it's something like in a database, you're always going to, in your application, you're always going to be searching for the same thing. Like many customers will log in at the same time. You have millions of customers that are going to be logging in at the same time. And every time the query has to be run, this join query has to be run for you to select something. You rather create a view where it just checks the view directly instead of running the query. So you can just say select all from the view, and then you get it. You can have a view of children view where you can get all the kids' accounts there in the view, and then automatically it just goes to that view to select all the children. So you can have like frequently accessed tables or records that you need to run joins or subqueries or any complex query on frequently. You can make them a view where the data is readily available. And these views automatically update with change in data in the table. And when I say go here, this view has been created. If I refresh this and I come to Secular now, I'll see something called views, and I'll see the views movie details here, and we'll see automatically has the details from the join. And I don't have to write that join all the time. I've already created a view that stores the result of my query as like a table. Views and tables must not have the same name. They have the same namespace. So a view is just like a table, only that you can't run the operations of a table on a view. The view just exists to have records from different tables, differently accessed, frequently accessed records across tables, like the results of a join, result of a subquery, and all of that in the view for more easy access and also for better performance. Is there any question?
Hello, ma.
Yes.
Sorry. Kindly just explain. Can you go over this? Sorry, once again. I just came inside. I was listening to it on my mobile phone. Can you the view that you talked about? Can you just do that?
Okay. So a view, we have something we call a view. It's the same thing as a table, except that you can't run the table operations apart from select statements and all that from a view. You can't do an insert and delete from a view because they do not actually hold the records themselves. They just run a query, like a result of a query, like the join that we did, and they store it as a table there. So a view is like a table that just stores the results of a query across different tables that you frequently access, that you need to get data from to improve your performance of your software or whatever it is. So we're saying that in the event that you need to always get the name the names of all the movies from a particular actor. And you have this interface on your app that you have built. And that interface will have a drop-down menu to select the name of an actor. And then when you select the name, it should automatically populate all the movies, title of the movies, and description that actor has acted. If you are going to do that with a secular database, you have to run a join like this. And imagine that we have billions of customers and they have to be running this query all the time, how that affects performance and resources. And so because these are frequently accessed functionalities, instead of running this query like this all the time, you want to store them in something we call a view. So the query is run and it's there. And every time you come to that view, the data that you need is available for you. And so we're going to be running all our table operations, select all from view name. It's just exactly how we select from table name. So at this point, you just say select all from view name where the actor name is equal to this. It's a better query to write than writing a whole join in between your script or your code for.
Okay, so the only thing we can issue on view is to select and view what is happening inside, right? Hello? Hello?
Hello, can you hear me?
Yeah, I can hear you. I said the only thing we can run in a view is just to select and check what is in the view.
Yes.
You cannot, okay.
Yeah, you cannot update or delete or do all those operations on it, just to select and filter and stuff from the view. Anything that modifies the view is not possible because it is not the record itself, it's just a copy of the rows in the table. So it's only when you update the original tables that the data in the view updates automatically. Okay. So we have seen the syntax of creating a view is to say create or replace view name. So it's written create or replace, and then you give your view any name you want. It must not be the same name as the name of any table because they have the same namespace, so they must have different names. So we gave these movie details before. You can create another name you want. So there are several views you can create. You can think about a functionality that you have on your software. When we get to the point where you start doing your final project and you're building software, you can think of a functionality and say that for this functionality, you need to select record from the database. And you don't want to run the select query because it's so long and complex within Python. You want to be able to have a table that has this information readily available to just say select all from table name. So that table you are going to be creating is called a view, where you run your join or subquery or whatever to just have the results readily available for your scripts to just select from that result already. So within software development, it makes your work easier. Okay. So that's the concept of view, and that's one of the topics we're supposed to look at next week. But because we might not have a class next week, I'm trying to combine last week, this week, and next week topics, and also for it to be able to help you in your assignment 3, for you to have these details. All the videos for next week will be made available earlier on so that you can actually go ahead and go forward with your studies. We also looked at how to group data, and we used the group by clause to group the rows with the same values into like summary rows. Let's say, for instance, we looked at an example previously of how we look at how many movies are in each rating group. So maybe we'll have different rating groups. We want to see what the rating groups are and how many movies we have in those rating groups. So we have PG, we have the ones that are rated and all of that. So in that table, in the film table, we have the film ID column. Let me go to the film table. So we have the film ID column in this table. We also have the release year column here. We have the rating column here. And we have different type of rating, PG, G, NC, 17, all that. But let's say we want to count how many movies are rated PG here. Let's say, do we want to have like on the home page of our application, maybe it's a movie app we are designing. We want it to, once the person logs in, to see 315 movies available. So if it's counting the movies, do we want to count it in categories? 315 movies available. Is it for a child? So it's PG movies we want to count. So let's say we want to now write the query that counts these things before it can display on an interface for anybody to see. And so we write the query like this. We are going to be selecting the column rating. So we want to select rating. And then if we look at this properly, let's look at it again. The only thing we can count here is the primary ID, which is the film ID column, the primary row, or the primary column, which is the film ID column. Because we can count this and say 1, 2, 3, okay, there are 100 rows there. So we can say, let us group it by the film ID. So every time you investigate your table, you want to see, we are trying to count how many movies are in each rating groups. So it's just natural to use the index or the primary key column as the count column. If, for instance, we want to count how many languages are here, we can use the language ID to say we are using it to group by, things like that. So this is where logical reasoning comes in, where you investigate your table, look at the columns available. Now we have the column called film ID. We know that film ID, if we count film ID, we'll know the total number of records that are here, and then we're now going to group these different films into the different ratings and now calculate the number of film in each rating. And so we'll do it like this. Select rating, select rating, and then we'll count. Select rating, count, film ID, and let's give it an alias as total, let's say as total film. And we're doing this from the film table, and we use the group by clause. We're grouping by what? The rating. So at this time, it's going to count the total number of movies in each group. When we run this, we're going to have each rating group and the total number of movies in each of the group like that. So we can automatically see now that there are 5 different ratings, and each of the ratings have this total number of films. Okay, is there any question?
Down from here.
Okay. So we said if we group by and we want to filter like this, let's say we want to group this by the release year, for instance, and we also want to say from that group of movies that we have, let me just use the same query we have, group by, but now let's say we're grouping by release year and not rating. We're not grouping the rating. Let's say we want to see all of the movies in a particular release year. And when it selects all of this, we want to still filter the groups. We use the having clause, and we say having. So we want to say, we want to group all of the movies, count the total number of movies that are in each release year, and also make sure that the rating is PG. So we'll say having rating is equal to PG, like this. And so when I say go, we're going to have, we only have 1 release year here, and then the rating is PG, and there are 1,000 total films there, like that. If we did not put the having condition, let's say the having condition is not PG and is G, for instance, we'll have another different total number there. So let's put G like this and go. And then we'll have another number. We don't have, the rating is G, grouped by release, we having rating G. Let's look at the different rating groups first. And then I think the rating group is G. We have a rating group called G. Let's see. I'll take this out first. So PG 1000. Okay, so now we're going to group this by rating and see the total ratings, the type of ratings we have. So group by rating, and we have a rating called G, PG, PG-13, R, and SCR. And so if we come back here and we say we are grouping by rating, and having rating is equal to PG. Let's say like this. Group by rating, then we want to filter this. We use the having clause. Having rating is equal to, let's say, G, for instance, or PG13, like we have there. And then it will give you the total number of film in just that condition that you want. So whenever you want to filter a group, you use the having clause. Okay? So this, we have summarized the topics that we have looked at previously. Let's try to use a different database to look at how to modify data. And then we'll create our own data using a scenario. I have here the classic models database, and this database, let's select that, and I will say show tables. This database has the customers table, employees table, offices table, the order details, orders, payments, product lines, and products table. Now, we want to see how to work with a different table with what we have done. Let's say we want to use like an aggregate function in MySQL. We say we have aggregate function. We just look at how we use counts to count the total number, like the frequency of a number, and we use the sum function to get like the addition sum. So let's look at this table called the customers table. Let's see what it holds. So let's say select all from customers here, and I have the customer number, customer name, and the contact last name, contact first name. We have different information and credit limits and all of this from the customer table. We have a table here called payments. This has a customer number, and the customer table has the customer number. So let's say these two tables are linked by the customer number. Let's say we want to get the total amount of money spent by a particular customer. So this was similar to one of your assignment questions. So we have this payments table that shows the customer number. We have customer number 103 spent this plus this plus this, but we don't want to manually calculate. We want to have maybe a view or something that just shows the total amount of money a customer has spent. In real life, one of the applications of this scenario will be like you want to automatically have your students, let's say we have a student grading system, and you want to automatically have something like the grades are ranked from the highest to the lowest grade, the top in the class. And so you create a view from their grades that calculates total grades from assignments, from tests, from exams, and calculates everything with this student's ID or matriculation number or something. Calculate all the grades from this one and put them in ascending or descending order. So without you having to calculate and see which student is the top, your database have them organized according to which person is top. So that kind of application. In this event, let's say we want to have a page on the customer profile to say the customer wants to see the total amount of money they've spent on our site. And so instead of having them different figures with different payment dates and their number, you want to just give them a total figure. You want this calculated automatically from the database before it displays. We can do that also using aggregate functions in MySQL. And so I'll say something like select, and I'll say select. So I want to get the customer number, and I want to add the amount column from the payments table. So I'm going to be selecting customer number, and then I will use the aggregate function sum. What column am I summing together? Amount column. So the column name is amount, and this is from the payments table. So I'll say from payments, and then we want to say we use the clause group by. And we are grouping this by the customer number, because remember that is the customer's sum that we want. So we are going to use the group by clause to group this. So let's say some amount have a nice name to say as total. as total spent or something like that. That is total spent. From payments, and we'll use the group by clause, group by customer number. And then when I say go, I'll have this. Customer number 103 spends this total. So if you go to the payments table and you manually calculate, you'll see that you get this total. But this query just makes it so easy for you to have this. And you can also store this in a view. Instead of running this query all the time, it's a bit like you have a table that tells you the customer number and the total spent, and it's updates in real time. As soon as a new order is placed and a payment is made, the view updates automatically to the new total spent. That's one of the functions of a view. Anything you are going to frequently access, any query you are going to frequently run on your site, any application you are building, where you have thousands of customers that will be running the same query through an interface where they just select a drop-down menu and the query runs behind the hood. You might want to just limit having complex queries and store these things in a view, because you know beforehand that this functionality I'm building needs this record from different tables of my database, and I want to select these things, create the join, the subquery, whatever, store them in a view, and just select all from that view based on any condition I want. Okay? So we also look at subquery. Before we move into how to insert record into a table, let's look at subquery one more time. What we are doing now is just revising topics and building up. So we said that we can use a subquery. For instance, in this scenario, let's see. Let's say we want to use a subquery here to get the number of customers that spent above, let's say 2,000 here. Or maybe 2,000 is too small. Let's look for a figure, let's say above 500,000 or above, let's say above 100,000, so we can eliminate some of these figures. Let's say this is what we want. We want to use a subquery to select this. So we have this query already. I will copy this because we're just going to be building on this query, and we're going to use a subquery to do this. We want to select customer number, the sum of the amount, and we name this as total spent. From the payments table, we group by customer number. Now we want to have a condition. When you group, we use the having clause. When you group and you want to have a condition on the group, you use a having clause. So we say having total spent, which is the new column we're creating. So we want to have total spent greater than, we say 100,000, right? Greater than 100,000. Let's even say we want to, now because we want to use subquery, let's say and we want to have another condition where the customer number is one of the customers whose address has a country in USA, for instance. So we are going to be doing this subquery where, first of all, we want to get all of the customer numbers, all of the customers from the customer table where the country column is equal to USA. And then we want to now run this query against the result of that query, which is going to be our inner query. So the inner query now that we'll write now is, we are first of all getting the total spent by every customer when the total spent is greater than 100,000, and then we use and we run a subquery here. And the condition we are going to use is that the customer number, so the customer number is in then the new query, which is the inner query we want to run, where we'll select all of the customers from the customer table where the country is USA. So we'll say in, and we're going to select, still customer number we'll select. From, the table name is customers. And we have a where class, where, and we have a column called country is equal to USA. So we have an inner query that selects all the customers from the customer table that resides in USA. We want to now get the total amount spent by all the customers that reside in USA, where the total amount is greater than 100,000. So you see how we use this to form a subquery. And if all is well, I click go, we have the customer number and the total spent. And we have every total above 100,000, and it went ahead to get this from a result that takes only the customers that reside in USA. And so we just have a limited number here displayed. So if you want to like have an application to see the different regions your customer are in, you have an international online market, you want to see, or you have a different kind of app to want to see the region where everybody lives, you want to see the total number of students from a particular nationality or something, this is what you do. So it now selects for you. Or you want to do a particular bonus for people from a particular region, you want to say, you want to display a different figure or a different price for them. So when they log in, you want to see their address, and the address is USA, for instance, or Nigeria, for instance, or Ghana, for instance. All you do now is to now filter by that condition. And you can do this in subqueries. If subqueries are too complex and is frequently accessed, again, you can save this result like this as a view, and you can frequently access it. Yeah?
You mentioned inner query. Now,
Yeah.
the inner query, is it the one that follows the in?
Yes.
Okay. Then the subquery, which one is the subquery, man, from what you put?
Everything here is a subquery. Collectively, we call it a subquery. No, before the inner query is the outer query. Together, we call both the inner and outer the subquery. So the name of the topic is just like we're using subqueries. But so subquery just means you have an outer query that you are selecting from the result of an inner query. So that's what subquery means.
So say that again. We have
an outer query, which is everything before the in is the outer query.
Before the in, okay.
Yeah, is the outer query. Everything after the in is the inner query. So the outer query is running its operation, the select statement, against the result of the inner query.
Of the inner query.
Yes.
Okay. Okay. So
yeah. Okay. So when we want to modify data, we insert records, we update records. And I'm not sure if we have looked at how to insert, update, and delete records, but let's quickly do that now. We have this offices table. Let's see what table we can use. Okay, we have this offices table. I'm going to use an example I've used in the previous class. So we have this offices table, and we want to say, we want to put a new office or a new address here. We are opening a new office location. We want it here. In MySQL, in SQL, we write the query to insert as writing insert like this. We write insert into, and then you specify the table name. So let me just use table name as a placeholder. So the syntax is insert into, then you put the name of the table in a pair of parentheses, all the columns that the table have that are not auto increment, like this. Let's say column 1, column 2, up to the last column, and then the values that you put in the column like this, and you list all the values within the parentheses of the values. So this is the syntax. You insert into, you put the name of the table, you list all the columns in the table and all the values. The columns and the values must be in the same order. So if the first column here is ID, the first value here must be ID, like that. So you insert into there. So let's say we want to insert into offices. Let's look at the offices columns. We have office code, city, phone number, address line 1, address line 2, state, country, postal code, and territory. We can see some of them are empty, null. Null means no data was entered here. So which means that these columns allow null. And the ones that don't allow null will have data in them. We're going to look at those table constraints in a later week's lesson. So we insert here, and we want to insert a new row into this table, a new office address. So we're going to write it like this. Insert into offices. So I'll put it like this. And we're going to be inserting the column names. We had office code, we had the city, we had the, I think it was the phone. Yeah, we had the phone. We had the address line 1. We had the address line 2.
Hello, ma'am. Sorry for cutting you. Before we do the insert, do we need to select the database first, or just go straight to insert?
Yes.
Like the class model, I believe the class model is the database in which the table office is, right?
Yes, so we're using classic model. So you always use, like in your MySQL workbench, the first thing you always want to write is use the name of the database. So I'll say use classic models.
Okay.
Like this. So that will be the first statement there. But me, because I already selected it manually, so I didn't use it here.
Okay.
And so even when you so even when you do your software, you develop your software, and in your back end, you always want to use that statement. We always write our codes like that. Okay, so this knows that is the classic models table that we are working with. So we insert into offices, the office code, we had the city, the phone, address line 1, address line 2. I think we have the state and country, then postal code. We have state, we have country, we had postal code, and then we have territory, right? Yeah, we have territory. Yes, I think we did that. And then when we do this, we want to put the values. And then in a pair of parentheses, you want to specify the value you are inserting. So let's say we're inserting 100. We put the name of a city. Let's say Grozile. Let's say we're putting the phone number. Let's put +17558555555. And then let's say we want to put the country. Now let's say the country is we have the address line 1 first. So office code, city, phone, address line 1 first. So we'll have the address line 1 to be, let's say, number 1 Success Street, something like that. And then let's say we have address line 2. Let's say we just have something like first floor. And then we have the state to be, let's put, we don't have a state. I will leave null there. And then we put the country to be, let's say, St. Lucia. And then we want to put the postal code, and let's say LC 01101. And then we have the territory. Let's say it is in South America or the Americas, like this. So we have specified the value that we want.
Hello, ma'am. I want to ask a question here.
Yeah.
Now, there's something I come across that maybe in doing this insertion and considering the value, we need to also take cognizance of whether it is integer or vat. I don't know. I wasn't getting that thing when that person was actually watching it on YouTube. Maybe
yes.
I didn't get that one because I said, okay, when we come to it, I will need to ask.
Yes, that's so we're going to look at the data types in MySQL when we're creating our own database and tables, and that is where you consider the different data types. If it is a string or varchar or character, you quote it. If it's a number, you don't quote it, like this. If it is null, it's just a keyword, like that. So that is another topic that we look at in next week's lesson, actually, where you see, you don't consider that while you are inserting. You already know the values you need to insert. Once that value is not a number, you don't put a quotation. Once it's a number, once it's not a number, you put a quotation. Once it is a number, you don't quote, right? Once it is a keyword like null, true, false, you don't quote also. Okay? Once it's a keyword.
What about the phone number? The phone number that you quoted, is that one excluded?
Because I put a plus here, which makes it not all numbers. If there was no plus, then it should have just been no quotes. Okay. It should just be all numbers. Yeah, because the plus sign now makes it a character that is not a number. Okay, so we are going to look at the different data types when we create our own database and we're inserting record. Then you take note of the data type of the column and the constraints that are posed on those columns. So when I say go, we have inserted. So when we go to the offices now, we are going to see that we have that new record that we have here, inserted here, as office code 100 that we just did. If you
let me ask you a question, ma'am. Sorry, ma'am. Now, this thing you did, okay, let's assume a large organization that is just they want to do a database for their what's it called, their staff. Now, are we going to be as a database administrator? Will the person be picking it one by one for each staff? Maybe they are doing for staff, for example. Is it going to be picking it one by one, or there's a template the person can do and run it in such a way that it will be easier? Because I look at picking it one after the other as cumbersome. You understand what I'm saying? Is there a way to automate it, kind of, so that
you can't automate, but you can insert more than one value at the same time, like what we just did here now. Let's come back here. I just inserted the first one, right? And instead of me to put my semicolon here, if I want to insert the second one, I will put a comma and put this and put another set of values here. So everything will be like a comma separated list, a pair of parentheses, and all the values. So let's say I'll copy all of these values here for the second insert value that I want to put here, and I'll change this to, like, say 200. This is going to have another name, for instance.
So that means we'll still need to be imputing it, after we have copied, try to change it manually, right?
Yes, you need to impute it. This is the easiest you have to go. Then once you are inserting records like this, there's something we say insert ignore. So in the event that it already exists, it does not halt the program or result in an error. It just ignores whatever already exists in the database. Let's say you have entered it before, you can't remember where you stopped, you started all over again. If you use insert ignore, it's going to ignore the ones that are there already and just put in the new ones for you. Okay?
I'm looking at possibility of human error, but thank God this one we handle that. That insert
ignore, yes. So it will disregard all the rows containing multiple data. And so this is it. If we do like this, and let's say we change this thing to determination street, let's just try to insert a new record while we have something that already exists, and we put this as second floor. When I say go, it will ignore the first one, but inserted only one row. So you say warning here, duplicate entry for 100 for primary key, because that exists, but it went through to insert the second one. And when we come here, we see 100, we see 200. The first one, it just ignored this, it inserted the second one that we want there. So if we want to, for instance, say, we made a mistake with this one. It's not Castries we're supposed to write. We want to change the name of this city to something else. And we have seen that this city is a mistake. Oh God, and I don't want to delete the whole row. I need to just update this city. When you want to update, you need to look for a unique column for that table. All tables will have an index or a primary key column that are always unique by default. In this case, it's the office code that is unique. You can't insert two office code that are the same in this record. Even if you have 1 million record, the office codes must be unique. And so when you want to update, you need to tell MySQL what row it is updating, what uniquely identify that row that it wants it to update. And that is why you will now use that row as the condition for update. Let's say we want to change the city from Castries to something else. The syntax for update in MySQL is update, and then you put the name of the table, and this table name is offices. So update, table name, set, column name. The column name is city. So we want to update the table called offices. We want to set the column called city equal to, let's say we want to set the city is equal to, let's say Rodney Bay, where. So the where now is the condition for the update. Where will it update? Because if you put it without the where clause, it means that you are updating all of the city column to be Rodney Bay for all the tables, all the table row down. And so you are going to have a wrong table where if you have 1,000 records, all their cities become Rodney Bay.
Because can you go over that again, ma? Please, can you go over this statement again? I
okay.
Get that.
So you write update,
okay,
table name, set, column name, is equal to the
that
value
we want to change, right?
Yes, the column you
That's
want
the
to
place we want to change. Yeah.
Yes. So you set the column you want to change equal to the value you want to change it to. Then you put a where clause. What is the condition for the change? Because if you don't put the where clause, it is going to change all of the columns, all of the rows for that column city into Rodney Bay, because it doesn't know what to update, so it updates the entire table. That the whole column city will become Rodney Bay. If you have 1 million record, all of their cities become Rodney Bay. It now becomes a problem. So you want to tell it what uniquely identifies the row. Whose record do you want to change? So we'll say where office code, since office code is the unique one, is equal to 100. So it will say, okay, I'm going to be changing the city of office code 100 from what it is to Rodney Bay. Currently it is Grozile, and when we say go, and we come back here to look at the offices table, we've seen that only this one is updated and changed to Rodney Bay. If we did not put the where clause, all the cities here are going to change. So when you're updating, make sure you have the where condition. If your intention is to update a particular row, if your intention is to update the entire table, then you can just run the update query without a where clause. Okay? Any question?
No question.
Okay. So let's look at delete, and I'm assuming when it's too long, you will not get the point, and maybe another lesson we're going to go more deeper. So we'll do the delete and end today's lesson, and then we're going to look at more topics later on. But for delete, it's just a simple statement where it's just almost like the update statement. You have to specify a delete condition. If not, you're going to be deleting all the records on the table. So you put it like is delete. So we say delete from table name. So we're deleting from offices. Let's say we want to delete one of the records we put in from offices, where now we want to delete based on the office code, where office code is equal to, let's say, 200. So if we don't put the where clause, delete from offices, we'll delete everything on the offices table. So you want to make sure for update and delete, you have your where clause, the condition. If your intention is to delete a specific row, a specific record based on a condition. If you want to delete every record from people from where the city is USA, you don't want to have any USA in your record, you want to delete. You don't want to have any Nigeria in your record, you want to delete. You will put the where clause, or where country is equal to Nigeria or something. So if you have 10 records that the country is Nigeria, it will delete all 10. If it's just one record and you use the unique ID for that, which is the office code, it will just delete only that one of 200. And when I come here, I will see that that record has been deleted from there. If we use, for instance, where country is USA, we'll have 3 records deleted at once. I don't want to delete any record that is here because I'll use it for other classes. I will only delete the one that I have created here. So I'll say delete from offices. Where office code is 100. And I say go, and it's confirmed, and we get this deleted. Now note that I'm using PHPMyAdmin. It asks me that confirmation. If you're using MySQL Workbench, it just goes ahead to delete what you need. So I've deleted every record that I inserted. And so this is how we modify records in MySQL. The syntax of SQL is actually really the same across the different relational database management system you use. Even if you use Postgres SQL, MySQL SQL structure is basically almost the same, with just little variations across the different management systems. Okay. So I don't know if you have any question. We will end this lesson here, and then we're going to combine more lessons later on. Maybe I will try to see if we can have one next week. Next week is not a convenient week for lessons, but based on the fact that we did not touch on a topic that will help you in your assignment 3, I was hoping I would have covered that, but it will take us more hours to do that. Okay. So I don't know if you have any question. Anybody has question?
Okay, man. Let me ask, what we did today, is it the create and the crude they talked about in database, update
Yes.
and the rest?
Yes,
Okay,
that's what we
okay,
did. Yeah.
okay. Thank you.
All right. So thank you, everyone, and enjoy the rest of your weekend.
Thank you.
All right, thank you.
Okay.